Okay, so as he's just said, my name is Lucas, and today I'm here to talk to you about JavaScript Fatigue, which is like the feeling you get when you're overwhelmed with so many packages, like with so many decisions we gotta take. And I've been maintaining Chai.js and Sidon.js for a long time, and I've got a quite wide view of this phenomenon, and I think I can find some reasons why this is good, and this is what I'm gonna try to tell you today. So I've written a blog post about this a while ago, and it was very controversial. Yes, I do use spaces, but that's not what my talk is about. What I'm going to teach you today here is something people don't usually teach you in college. And please don't get me wrong, I think college is great. I just think it lacks a very important subject called Realities of Industry 101. So the first truth here is that software solves business problems. Most software there, it's boring, doesn't have any high performance constraints or anything like that. It's not the software we would like to work with, but it solves someone's problems, and that's our main goal, that's our objective, right? And that's because we're actually not paid to write code. We're paid to solve problems, and actually the less code you write, the better. And even if you can solve a problem with no code at all, that's even better, because there's nothing worse than writing a good code that should not have been written in the first place. And that's all because technology is not a go. Solving problems is a go. And the only thing that matters is cost versus revenue. So the more revenue you can generate and the less cost you can have, that's the best thing you can get. And we don't write bug-free software because we like bug-free software. Because in fact, if our clients wanted bugs, well, we could write them all day, right? And we don't write beautiful code just because we as programmers value beautiful code. We write beautiful code because beautiful code makes us more productive in the long run. And all these things, like launching rockets into space, self-driving cars, robots, AI, all that, I'm sure Elon Musk thinks it's pretty cool, but it actually happens because people have economic interests behind it. And maybe I should not even call this section Realities of Your Industry 101. I think that's the wrong name. I think I should call it Realities of Capitalism 101. And well, if solving problems is the only thing that matters, not just writing code, maybe we should pay attention to other related aspects of software development, such as design. In this study in '75, Boehm has shown us that 36% of the errors in the softwares he was studying came from coding, whilst 64% came from design. In the NASA Apollo project, 72% of all errors were design errors. And, well, having clear requirements, clear goals is very important because, well, without requirements or design, programming is the art of adding bugs to an empty text file. And you realize how important good design is, especially if you remember that our objective is to decrease costs and increase revenue. And good design adds value faster than it adds cost. So these things, all of them, like Mocha, Chai, Babel, React, all of them, they don't just exist because someone thought it was cool to write them. They exist to solve a specific problem. And that's why you should use them. You should know why you're adopting a certain technology before using it. Because JS fatigue happens when people use tools they don't need to solve problems they don't have. And many times they do that in the name of premature optimization. And as Donald Knuth said, premature optimization is the root of all evil. So please don't solve imaginary scaling issues if you don't have scaling issues. Don't waste your time with that. Don't add unnecessary complexity to your software. Because the whole purpose of software engineering is to control complexity, not to create it. And keep in mind that the greatest performance improvement of all is when a system goes from not working to working. So if you remember test-driven development, well, that's what it's all about, right? And I'm not just talking about writing tests before you write code. When I mean that TDD is important, I mean it's important because it helps you take smaller steps towards a solution. It allows you to progress gradually. And then, by doing that, you reduce the scope of the decisions you got to take, and then you have less options for solving each problem. And this decreases a lot what we call analysis paralysis. And, well, analysis paralysis is, for example, what happens when you open Netflix. So you have so many choices, you don't know what to watch, and then you spend 3 hours choosing something, and in the end, you watch nothing, right? This is analysis paralysis. And if you've ever opened Netflix, you know what I'm talking about, because more choices actually mean less satisfaction. In this book, Barry Schwartz says that as the number of options increase, the cost in time and effort of gathering the information needed to make a good choice also increases. So we get more attached to it, and consequently, we have more frustration if we make the wrong choice, and we get too attached to that, and we spend lots of time thinking about what we're going to do instead of doing something. And that's because our willpower, it's limited. So the more you use it, the more tired it gets, and the poorer your decisions get. So this study shows it quite well. It shows that your willpower is just like a muscle. So here, we have a graph that shows you how many favorable decisions you just give compared to the time of the day. So as the day starts, they're very prone to giving favorable decisions. And then, as it progresses towards lunchtime, it drops steadily to 0. When they get back from lunch, it goes all the way back to 65. And the same thing happens again when they're approaching their break, right? So with this chart, we learn 2 things. First one is that your willpower is just like a muscle. The second one is that if you ever commit a crime, you better be the first one to be judged that day. And maybe we're not just JavaScript fatigue. Maybe we're, in fact, decision fatigued. OK, but you know, what about JavaScript? Well, I think there's no better way of showing how serious this is without showing you a bunch of impressive numbers. So this is not the price of Bitcoin. This is the growth of NPM until the end of 2017. So as you can see, it has grown a lot more than any other package managers out there. And I've given this talk a few times before, and this number always grows. Yes, that's me with the wizard hat. So it always grows. And right now, we have 700,000 packages on NPM. Actually, not right now, yesterday. That's 536 packages a day. The growth rate in Paris is 198 people a day. So we need more people to test all those packages, right? And the NPM registry traffic has grown 1,000 times in the last 5 years, from 480K downloads to 480 million. That's a lot, that's huge. But how did that happen? How did we get there? Well, every tool has its reason to exist, right? Transpilers, for example, they come from the need we had to write next-generation code and make it work on many platforms, even the ones that are outdated, and so that we can have things such as JSX in our code. Module bundlers. Who here has ever had to write a script tag on HTML? Oh, God, painful times. Well, if you remember that, you remember how error-prone it was. You know, we had lots of problems with dependencies, so one script tag had to come before another, and then we had all these problems with like multiple versions of the same dependency. It was horrible. So we needed a good module system, and we needed a good way to make it work on the browser and make it optimizable. So this is why these tools exist. Front-end frameworks, well, they exist because if you have to worry about your display logic and your business logic, well, that makes things very, very hard, right? So they just provide us abstractions so that we can focus on what matters. And abstractions, they're necessary to reduce the cognitive load of how things work so that you can focus on creating. That's the whole point of having frameworks. And all of these tools, they have something in common. And this thing is that they happened because the web platform moves too fast. So every day there's something new appearing, and we need to solve more problems because there are new problems appearing all the time. The web moves too fast, and standards don't move that fast. So if we had to make a standard for things, imagine like having a committee and drafting proposals and getting people to approve them. That takes a lot of time, right? So by having frameworks, we allow natural selection to happen. So when you allow the community to come up with solutions, this allows us to have many options to pick from and choose what's going to become a standard and what is not. If you remember, I think in the last year, things have become a lot more standardized. Like, we found the correct way of doing things. JavaScript was just too immature, and now we are eventually getting there. And this is also good because it has a lot to do with the Unix philosophy. So in JavaScript, we have so many tools because many of them do one thing, and they do it well. In the test ecosystem, for example, like if you want to write tests, you can have a separate assertion library, and a test runner, just like Chai and Mocha. And if you want to switch one of these pieces, you can. And this is good because so much complexity in software comes from trying to make one thing do two things. And it's also good that people write programs that work together. So with more tools, we can just add new things to our stack without too much work. And all our tools, like all the things we have, they're not new. NPM, well, we had Ruby gems, we had PyPy. We already had that. JSX, like mixing markup on JavaScript, well, we already had that with E4X a long time ago. Babel, it's just like, use the same compiler principles that have been around since, like forever. And Goop, Grunt, NPM, Webpack, all these things, we already had that in 64, and we call that NewMake, right? And actually, there are many projects that still use NewMake. In Chai, we use NewMake, not because we're hipsters, but because it solves our problem, and it's quite simple. So React Native, mixing like web technology in order to target mobile, well, that already existed with CV and WRT. Like, I've never used that in my life. Very thankful for that. But, it existed. But how should we deal with it? Well, the first thing to notice is that you don't need to know everything. So you can learn things as you reach problems, and you can tackle things gradually. So if you reach a point where you cannot progress without, like finding a better solution, finding what solves that piece of problem, well, then you go and you study that specific solution, and then you do something about that problem. You don't try to learn everything, like that's impossible. And that's because every great developer, got there by solving problems they weren't qualified to solve until they actually did it. So if you're learning, also try to start from the beginning, like learn JS fundamentals, HTML, computer science fundamentals, and all that. Because every technology that's advanced enough feels a bit like magic. So when you learn the fundamentals behind that, you can then like remove a bit of the magic, and actually, if something goes a bit off the way, you know what's happening, you know what's wrong. So, but sometimes it's a bit hard, it's just like trying to learn how to swim by studying dynamic of fluids. Sometimes you just gotta like jump into the pool and try not to die, maybe. Don't be too attached to a single technology. That's also very important. Don't be defined by your stack, because if you're a good problem solver, if you're a good engineer, that will take you anywhere. Like for example, Rob Pike, I'm sure like any company that uses any language would like to hire Rob Pike. And it's not because like he invented Go, he's very good at Go, or I don't know, almost everything, but like it's because he's a good problem solver. And I have a tail here to illustrate that. So if you can turn off the lights, that'll be quite nice. Can we do that? Oh, yes, no? Only if you don't mind? Oh, that's nice. Okay. So this tale is called Master Fu and the Recruiter. So a technical recruiter, having discovered that the ways of Unix hackers were strange to him, sought an audience with Master Fu to learn more about the way. The recruiter said, I have observed that Unix hackers call or become annoyed when I ask them how many years of experience they have in a new programming language. Why is this so? Master Fu stood and began to pace across the office floor. The recruiter was puzzled and asked, what are you doing? I'm learning to walk, replied Master Fu. I saw you walk through the door, the recruiter exclaimed. And you're not stumbling over your own feet. Obviously, you already know how to walk. Yes, but this floor is new to me. Upon hearing this, the recruiter was enlightened. Okay, I think we can turn on lights now. I hope you like that. It was like my magic moment. Okay, I'm just going to keep on going. This light's nice. Also, another important thing is that you should do things that don't scale. So, like, don't try to solve imaginary scaling issues, as I've said before. Like, try to get something out the door, test your concept, because as I've also said, the worst piece of code is the code that should not have been written at all. Focus on what matters. Focus on solving problems, not just writing code or using this or that tool. AKA, don't do bike shedding. And if you have time for questions, please ask me where the term bike shedding comes from. And what this whole talk is about is not getting ahead of yourself. find problems before you actually try to solve them, and build things. So sometimes when you follow tutorials online, well, the authors, they just show you problems to demonstrate an abstraction, and most of the times those problems don't even exist. So when you build things for yourself, when you build applications for yourself, you see that certain problems, certain abstractions are kind of common, and then you learn when a certain solution should be put in place. So this is why it's so important to build things. And then it's important to learn the cost of abstraction, because first you learn the value of abstraction, then you learn the cost of abstraction, and only then you're ready to engineer. And now a more philosophical question, but I promise it has a lot to do with what I'm talking about. So what are we? Do you call yourselves software engineers? Anyone? Software engineers? Programmers? Software architects? Okay, so I've got a question for you. How many times have you seen buildings collapsing, and how many times have you seen software crashing? So I think that engineering might not be a good term. Engineering has been around since forever, and software development is quite recent. And I've got a good analogy to demonstrate this. So this city is the city of Barcelona. When you look at it from this angle, it's a quite common city, just things all over the place, not anything special. But when you see it from above, you see that it's very, very organized. And well, at that time, they couldn't predict what it was going to look like. They couldn't just destroy everything and build everything from scratch, right? It's a city, people move around, and things happen. So they let it grow, and they adapted organically. And this is what I think we should do. They solved one thing at a time, and they were organizing as they went. So I think that actually, you should not be an engineer or an architect or something like that. You should be a town planner, because that has a lot more to do with what we do, right? And that's because software is flexible, whilst engineering is not. Or build time is compile time. We can build things as many times as we want. We can spend more time designing and thinking than actually building things. We can break things, and we can always change them. So be a town planner. Let your software grow, adapt as needed, solve one problem at a time. And this is including scaling problems. Abstractions, they only work well in the right context. And the right context develops as the system develops, which is why it's so important to let things grow and let problems arrive. Another very important advice I've got from a friend in college was that you should strive to be lazy. So if you can be lazy, if you can automate something, if you can make your life easier, if you can make yourself completely, if you can throw yourself out of work, then, that's what you should do. So strive to be lazy. Focus on being lazy. There's always easier ways of doing things. And sometimes you might not realize that, which is why it's so important to come to places like this, come to conferences like this, and talk to people. This will help you realize the things you could be improving. And be curious, read widely, try new things, because what most people call intelligence just boils down to curiosity. But if I had to sum up this whole talk in a single advice, that would be to go out there and solve problems, because this is, in fact, what you're paid to do. And this is it for today. My Twitter is up there at the Wizard Lucas. It has a picture of me with a wizard hat. It's quite easy to find. And here's a few references I quite like, which inspired this talk. All these slides are going to be available online, and I'll just post that on Twitter. And I think this is it for today. Thank you very much.